Next is BCD Adder. So BCD Adder makes use of BCD Addition. So before we talk about BCD Adder circuit, we should know something about the BCD Addition. We know that a BCD number is represented by 4 bits for every digit in decimal. So if it is say 12 in decimal, that is represented as 0001 0 0 1 0 in BCD. So every digit in decimal is represented in 4 bits using binary coding. So that is binary coded decimal number. So using 4 bits, the largest number that you can represent is 9 in decimal. So that is 1001. So this much we know. So in the case of BCD addition, again we are making use of 7483 IC like we used in adder subtractor IC in binary adder subtractor. So when you are doing BCD addition, suppose your answer is you can have different types of answers. That is, suppose you are adding two numbers, say 1 in BCD plus this is 1 in BCD plus say 3 in BCD. So what you will get is 4 in BCD, or the answer will be 0 1 0 0. That is, you are adding 0 0 0 1 plus 0 0 1 1. So you are getting 0 1 0 0. So suppose you are adding say 2 in BCD and 8 in BCD. Now no issue with these, this answer is correct. So if you are adding 2 and 8 in BCD, 2 is a valid BCD number, 8 is a valid BCD number, that is 0010 plus 1000. Both are valid BCD numbers. But what is your answer? If you do binary addition, which is what 7483 IC does, 7483 is a 4-bit full adder. Yes, so 4-bit parallel adder, sorry. So it will be doing normal binary addition only, 7483. So when you add this, what will your answer be? It will be 10. But this is not a valid BCD number. This is invalid as far as BCD is concerned. Yes, so this you can't use because your answer should also be within 0000 to 1001. So the maximum answer you can get is 9. But these two are valid BCD numbers. So you should be able to get an answer which is greater than 9. So 10 also you should be able to, if you want 10, 11, 12, 13. That is my input. If you see, inputs are both BCD numbers. So inputs are both BCD numbers means the maximum addition that you can do is 9 plus 9. Two valid BCD numbers. Your input should be valid BCD number. So 9 plus 9 is the largest number which you can give to the input. But what happens? 9 plus 9 is 18. So 18 is again it requires 2 bits. Sorry, 2 4-bit combinations. That is 8 bits. Okay. So in order to represent this in BCD, you need 8 bits. So that is another problem. So we have three types of answers. The first case is if your answer is between 0000 to 1001. If your answer of the BCD addition falls in this range, then no issues. Your answer is correct. Your answer is a valid BCD number. No issues. That is your answer. Second case is if your answer is between 10. This is binary 10. If your answer falls between 10 to 15, or you can say that is not BCD number. If your answer is between 10 and 15 in decimal, those are invalid. You can't represent it in in 4 bits. You need 8 bits for to represent 10 to 15. Yes. Third case is again your answer is between 16 to 18, because 18 is the largest number you'll get in the output, because 9 plus 9 is the largest addition you can do with valid BCD addition. Now why am I separating these two? Because between 10 and 15 you will get an answer. If your answer is between 10 and 15, you will get an answer in binary, the correct answer in binary, but not BCD. Because like in the earlier case, if 8 and 2 is added, you will get 1010. The answer is correct as far as binary is considered, but this is wrong as far as BCD is considered. Okay. So likewise in the case of say 7 plus 8, again answer is 15. The answer is correct if you are taking it as a binary number, but the answer is wrong if you are considering it as a BCD number. You can't represent it in 4 bits. Now the third case is answers between 16 and 18. So 16, 17, 18, these three numbers you can't represent even in binary using 4 bits. You need 5 bits. Because 16 is 1, you need 1 followed by 4 zeros. So that is 15 in binary. Sorry, 16 in binary. And 17 is 1001 and 18 is 10010. So these three numbers you won't get the answer correctly, even if you are taking it as a binary. So these are the three sets of answers which you will get. First case, if you are getting, it is completely correct, no issues. Second and third, you have issues. So what will you do with the second and third? Now if you are considering the third one, I talked about 8 plus 2. 8 plus 2 is 8 plus 2. So your answer will be 1010. Sorry, not the second, no. I mean in the third case. Third case is 8 plus 8, suppose. 8 plus 8 in order to get answer as 16. So this is your answer. So when you are using 7483, this one will come as the carry out. Because in the sum section you have only S3, S2, S1, S0. This will appear as the carryout. Likewise, if you are doing say 8 plus 9, again you have the carryout. 8 plus 9 is 17. And suppose you are considering 9 plus 9, which is 18, then you have the carryout. So in the third case, all the numbers will have a carryout. Here you will have carryout equal to 1. That is a common issue, common pattern you can see in the third case. So if your answer is greater than 15, then you will have a Cout equal to 1. So if Cout is equal to 1 in binary addition, you can understand that your answer is greater than 15. Okay, so that is one pattern we have identified. Now in the second case, second and third case are the invalid cases. So third case we solved. We'll just find out how we'll solve it, but this is a pattern we have identified. In the second case, see, if your answer is say 8 plus 2, so your answer is 10. This is your actual answer. Okay, so suppose you add 6 to this. What do you get? Yes, so if you add 6 to this, you get 0 as the answer. Okay, that's a carry. That carry I am eliminating. So actual answer is 10. I am getting 0 as the answer. I'll consider one more. So suppose it is 8 plus 3. 8 plus 3 will give you 11. If you add 6 to that, you'll get 1. So your answer is 11 and I am getting 1. If suppose your question is 9 plus 3, then you will get 12. Again, if you add 6 to it, you will get 2. That is, your answer is 12 and you are getting 2. So in short, in the second case, whatever answer you are getting, that is, if the answer is greater than 10 but less than 16, that is, your answer is between 10 and 15, then add 6 to the answer. Add 6 to the answer and you will get the lower digit of the answer. You won't get the entire answer. You will get the lower digit of the answer. If the answer is 12, you will get 2. If your answer is 10, you will get 0. If your answer is 15, you will get 5. So the lower digit, between 10 and 15, the lower digit you will get as the answer. Okay. So that is, these are the two rules which you will be using. If your answer is between 0 and 9, then you don't need to do anything. If your answer is between 10 and 15, add 6. If your answer is greater than 15, then Cout will be 1. So Cout is 1 means your answer is greater than 15. So we'll take the invalid cases. Okay, so and we'll just set a bit. So what are the invalid cases? Suppose it is I3, I2, I1, I0. All between 10 till 9. If the answer is between 0 and 9, the answer is correct. From 10 to 15, it is invalid. Okay. 14 and 15. 16, 17, 18 I won't consider because you have only 4 bits, and the 16 to 18 you'll be checking only the C out. Okay, so these are the invalid cases. So this is the second case we are dealing with. So if any of these comes up, then add 6. Okay, so if any of these happens, then add 6. Okay, so when do you add 6? When do you add 6? If it is between, from that particular table, it was I3, I2, I1, I0. You are writing the K map for Y. When do you add 6? That is what we are finding out. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So when the answer is greater than 9 but less than 15, 9. So this is 9. So this is 10, 11, 12, 13, 14, 15. So if the answer is any of these, then add 6. So we'll just solve this. So what is Y? Y is equal to I3, I2 plus I3, I1. Yes. So if your answer is any of these, or okay, if this is, if Y is 1, that is I3, I2 plus I3, I1. If this is true, then add 6. Okay. So it is I3, I2 plus I3, I1. So add 6 when I3, I2 plus I3, I1 is true, and also when C out is equal to 1. So this is the case when your answer is greater than 15. This is the case when your answer is less than or equal to 15 but greater than 9. Between 10 and 15, this is the case. Between 16 and 18, this is the case. So this is the total invalid case. Okay, so suppose your answer is 16. Yes, so you're adding 6. This is your carry. When you're adding 6, this is your sum. So 16 is your answer, you got 6. So suppose 17 is your answer. Then you are getting 7. If 18 is your answer, eight is what you are getting. Okay, so if you add 6 to an invalid answer, you will get the lower digit of the answer. That is the rule for BCD addition. If you have an invalid answer, then add 6 to it. Then you will get the lower digit of the answer. So how do you find out whether it is an invalid answer? If your answer makes this particular equation true, or if C out is equal to 1, then your answer is greater than 9. So in that case, add 6. So when you get the answer, you're getting it as 6 or 7 or 8 or 0, 1, 2, 3. So how do you know that the answer is an invalid answer and what is showing up is only the lower digit and not the actual answer? That is, if you are doing 1 plus 1, your answer is 2. If you are doing 8 plus 4 also, your answer is 2 only, because you are getting only the lower digit. That is where this particular thing will happen. If this is true, that is this is equal to 1, you'll place an LED there which shows that the answer is invalid. And if that LED lights up and you're getting an answer at S3, S2, S1, S0, then you know that the answer is an invalid answer and what is showing up is only the lower digit. If this is not true, that is, if the answer is not invalid, your answer is this is 0 and then you're getting a 2, then that means that the answer is valid and your actual answer is 2 itself, not 12 or anything greater than that. Okay, so this is the logic behind BCD addition. So for that, we have to draw the circuit diagram using this. So the equation was y equal to, or say it is x equal to y plus C out. X is X is the LED which will light up when you have an invalid answer. And Y is I3, I2 plus I3, I1. Right? I3, I2, I1, I0. So this was the ones. So this is I3, I2 plus I3, I1, right. Okay. So you have the 7483. You have A3, A2, A1, A0. You have B3, B2, B1, B0. You have C out. You have C in. And here I mentioned it as I3, I2, I1, I0. This is what is I3, I2, I1, I0. Okay. So this is my equation. So I am giving the inputs here. Yes. Now when should you add 6? So in order to add 6, you need another 7483. So you have two 7483 ICs. So you'll be applying the inputs to the first one. You're getting the answer here. So my X is I3, I2 plus I3, I1 plus C out. I3, I2, I1, I0 is this one. C out is this. You are adding 6 using the second IC. And your final result is S3, S2, S1, S0. So this both are acting as adders. So I'll keep it at logic 0, Cin and Cin dash. Both I'm shorting and giving to a switch which will be kept at low. So what you'll be doing in the first IC is A3, A2, A1, I0 plus B3, B2, B1, B0 plus Cn which will be 0, and that you will get at I3, I2, I1, I0 and C out also. Okay, so my X is I3, I2, I1, I3, I2 plus I3, I1 plus C out. So I will give this here. So this is my actual answer. That is, what are you going to do? If your answer is say 11, then I'm going to add 6 to it. Yes, that is, if your answer is 11, I'm going to add 6 to it. So in order to know that this is 11, that is, it's a number greater than 9, then I have to make use of this I3, I2 plus I3, I1 and C out in order to know that it's a number greater than 50. So this I will solve. That is I3, I2, I3, I2. So that is an AND gate plus I3, I1. I3, I1 so that is an OR gate. I3, I2 plus I3, I1 is an OR gate plus C1 plus C out. Sorry. You can also use NAND combination, whichever you like. So this is my X. So when X is equal to 1, then add 6 is our rule. So add 6 to what? Add 6 to this answer. I3, I2, I1, I0. This is my I3, I2, I1, I0. I2, I1, I3, I2, I1, I0 plus 6. So I3, I2, I1, I0 has come to the next IC plus 6. Add 6 when X is equal to 1. So when X is equal to 1, add 6 means what? 0, 1, 1, 0. So when X is equal to 0, what should you add? Add 0, because this is my answer. That is, if my answer is say simply 2, then that's my valid answer. So X will be 0. So in that case, 2 is the answer. So just add 0 to this. Don't add 6. So 0, add 0 or add 6. This is in the case of invalid answer and this is in the case of valid answer. So what? This is same and this is same, only this is different. Okay. So A3 dash and A0 dash is always 0, whether it is a valid answer or an invalid answer. Only A2 dash and A1 dash will change. So X will be given to A2 dash and A1 dash. If X is equal to 0, then the answer is valid, then add 0. If X is 1, then A2 dash and A1 dash will become 1, so that it will add a 6. And A3 dash and A0 0 dash will always be logic 0 because that is 0, then next two bits will depend on x. 0 0 0 0 or 0 1 1 0, that will depend on x. So this is for BCD addition. This is for normal addition. If the answer is invalid, that will be computed by this. If x is equal to 1, then it is invalid, so add 6. If x is equal to 0, then the answer we get here is valid. So add 0 and you'll get the final answer here. So suppose we'll just check. Suppose my answer is say 2. Answer is 2. That is I3, I2, I1, I0 is like this. So I3, I2 that is 0. So here it is 0. Then I3, I1. So that is also 0. So x is equal to 0. So here what comes? 0, 0, 0, 0. So add 0. So what is here? Here already you had 0, 0, 1, 0. So 0 plus 0, 0, 1, 0 plus 0, you'll get the answer as 0, 0, 1, 0. At that time, you're connecting an LED here also. Yes. So here it will be a 0 and here it will be 0, 0, 1, 0. So when x is equal to 0, then this is my actual answer. Now suppose my answer is 12. If my actual answer is 12. Okay, so actual answer is 12, 1, 1, 0, 0. So I3, I2, so that is a 1. I3, I1, that is a 0. So x will be 1. So here you'll have a 1. So here it will be 0, 1, 1, 0. So if my answer is 12, then I can see that my x is 1 because I3, I2 is 1. So x is 1. So this is 1. So you are going to add 6. Add 6 to this. So it will be like this. Since C in dash is 0, it is plus 0 itself. So 0, 1, 0, 0 and this carry. So what you will get is 0, 0, 1, 0. You will have a carry out which you won't be taking. So when you see this, x is 1, so the answer is invalid. So what you are getting here is the lower digit. In the earlier case, this was 0 and your answer was 2. So that means that the answer is valid and your actual answer is 2 itself. If x is 1 and then you have an answer here, that means that answer is invalid and it is a answer. So suppose your answer is greater than 16, greater than 15. Then your C out will be 1. C out is 1 means x will be 1. Again add 6 and since x is 1, what you get here is the lower digit. Okay, so if your answer is say 16, this is my C out. So C out is 1 means x is 1. So add 6 to this. So your answer will be 6 with x equal to 1. So this is the lower digit.